Hello pilot nerds, this started off as a Flight Chops Patreon exclusive from the first night flying episode with the RV-14, but I thought it was worth sharing here. I intercut the story of my friend Thad having a complete communications failure that was ultimately caused by a bad light.
So we're out here at the hangar and we've got 172 with a radio interference problem.
Thad debugged and broke down the whole process of diagnosing this problem.
Gas undercarriage mixture, prop to go, switches, I'm secure, you're secure?
All secure.
So it worked out that he was in town when we did the first night flight in the RV-14 and he shot this B-roll. But anyways, here's all the selects from him describing his problem and then diagnosing and fixing it.
So I'm fairly green, I hadn't had any issues yet. There's a lot of traffic around and all of a sudden the radios just go to static. So I'm punching the squelch and it's not that. I try some different frequencies. They're all static. So here I am thinking this radio kind of crapped out on me. Switch over to COM 2 and it's all static too on every frequency. So now I'm feeling really clever. I'm like, all right, well, something's going on with I don't know what, but I came prepared. I've got my nice little handheld two-way radio here. Aren't I smart? So I turned this sucker on and it's all static too on every frequency. And at that moment, like, my brain kind of reset, because that was the last thing I expected to happen, was to get static out of my handheld. I'm probably, 80% of my CPUs working on flying the airplane right now. I'm thinking about, thankfully we were still outside of the Bravo underneath it, but we were in a busy area. I probably could have thought about turning on and off other systems. But it wasn't popping into my head at that point in time. We turned around and started heading back there. We're only 15 minutes away. Thankfully, at ADSB we were still receiving, so I could see that there's probably only one person in the pattern here. And we got back, and I was making radio calls, but I didn't know if anyone was hearing them, or if I was just messing up everybody else's radio as soon as I showed up.
Thad filmed the process of building his custom equipment for diagnosing this problem. A lot of this did not make it into the public episode, but it is very interesting, so I hope you enjoy it. And then coming up next, he'll use it to diagnose.
We are going to build an E and H field probe set so that we can try to localize some radio interference on a Cessna 172. We need just a couple things here. One is a coax cable, which I've got here, and I'm just going to cut it into two pieces. One will be the H field probe and one will be the E field probe. These things are ridiculously simple when you see how they go together. So these things were like $5 each, and I bought them on eBay. And then these were the same thing. I just bought two of them in case I screw one up. And then the other thing I bought on eBay was a broadband RF amplifier here. And this is just because, these antennas aren't going to pick up a lot of signal, so we want to amplify them before we pump them into the oscilloscope, so we get so we can get a good look at the signal. An H field probe is basically a piece of coax that is bent into a loop. I needed something round to use as a template, so I just got this nice piece of pipe sitting in my garage. We're going to use that. We'll fold the center conductor over so that it's contacting the shield, and then we'll solder the shield at the end of the loop to the shield at the outside of the loop and to the center conductor. It might be a little bit large for a gap, but this should do the trick. So what we're going to do here is use the probe that we built to try to find a substantial increase in signal in that VHF airband space. I've got the oscilloscope Fourier transform here zoomed in basically on 110 megahertz to 130 megahertz. That's the red line there, so that should really be capturing everything that's in airband. And if we have an interference source that's broadcasting in that space, we should be able to just, as we scan around with the loop, we'll find the source of the interference. Master on in here, and we're going to do nav lights off, and we're going to look for our signal. All right, we have the loop, and we're just going to kind of look for that signal that we're expecting to see. So I'm moving the probe back and forth, and we got nothing. All right, so now we're going to turn that nav lights on, and this is, when this has been on, all the radios were static. Even the handheld was static. when I was flying. And then when I tested on the ground, I had the same thing going on. We should be able to take the probe here, and we're going to scan the lamp here. We see a signal there for sure. We see a little bit of peak right around 120 megahertz. 120 megahertz is what's in the middle. If I back the probe off, it returns to nothing. And if I bring the probe up to the lamp again, you know, but that's only like an extra that's only a few decibels. Now, and I'm only looking at the red bar. The yellow bar is the raw signal in the time domain. We just really don't have anything that interesting. We do seem to have some repetitive signal in the time domain. I have a feeling that time domain signal is the switching fundamental. It should be between like 1 and 2 megahertz. So if we see, or 1 and 3 or so megahertz. So yep, I'm seeing about 2 megahertz measured by the scope here. No, 4 megahertz. Yeah, I don't know, 4 megahertz measured on the scope here. So that's probably the switcher, but we expect that to make noise because we saw the fundamental even on my little battery pack. Now, I'm not gonna lie here, I expected to see quite a bit more noise on the actually, but here's what I'm talking about. So this is 120 megahertz. Here's 110 down here. Here's 130. Here's 140. But you know, this if our floor was minus 40 to 50 decibels, and keep in mind that's after going through a wideband amplifier here. We're seeing 50% more noise with the light on there. Let's repeat the test. So we've got our radio here. And does it go all static when I turn the nav lights on, or has that problem magically gone away?
17 Celsius.
Oh yeah, it's full static. So even though that wasn't, and we're just going to do one more round here to confirm, you know, even though that wasn't as much additional noise as I had expected to see, you know, we still see it, and we see the static on the radio. Now we're going to look again to see if we get that broad spectrum noise as we get closer to the lamp. And I can see it already. Yep. It's right there in airband. It's especially around 130 to 140 megahertz and under 110 to 120. So is it the lamp? That's a funny thing. This isn't really conclusive. I would have expected the noise to be louder if it was the lamp. One other thing I can do here is go over to the airplane here and scan for that signal elsewhere, but all right, so now we're in the plane and we are going to look for that same signal right here on the switches. So I'm just going to take the probe here and hold it over the switch like so, and what we're going to look for is the same signal. So right now we see our, you know, minus 50, you know, minus 45, minus 50 decibel noise floor. And keep in mind these are not absolute values because I am going through an amplifier and I didn't calibrate anything. We're just looking for differences here. So I'm going to turn that nav light on, and the question is that signal there, and is it stronger? Okay, it's definitely there somewhat. This one's going to be a little harder to explain. I'm going to go ahead and, right here we have the signal, but it's only up to, you know, it's a good 5 decibels, 10 decibels quieter than the signal at the lamp. These peaks are so fat, like they aren't sharp peaks, so, you know, that's kind of indicative of broadband radiation there. So, and then that's kind of what we're seeing. So let's check out the radio once more. This kind of shows that the interference might not be as bad at 125 megahertz. So let's try to tune in. Who's around 125 megahertz? I think Minneapolis Approach has a 12565, 12555 or something. We can tune into and see if the static isn't as bad there.
Lakeville, Air Lake Airport. automated weather observation 2.
Okay, so now we're just doing a kind of a subjective, audible interference. Let's go 1, 2, 5. Woo! Alright, so much for that theory. So 1, 2, 5 isn't quieter. 1, 3, 5-ish look like it would probably be the worst. And we're definitely getting static there. I mean, it's not like this is a scientific measurement here with the handheld frequency selection. I was just curious of where we saw that. I don't know if we can make any conclusive statement about the LED, but I mean, it's definitely emitting noise. And there's definitely noise on the circuit, and that's probably a harmonic of the switching supply, because we did see the switching supply fundamental there at about 4 megahertz. But yeah, further debugging is going to be required for this one. It's not cut and dry. I think the next step would be to take that lamp off of there and run it on the bench and see if we get the same kind of interference, and see if we can localize it a little bit better, and to maybe put a dummy load on there and see if we get the kind of same behavior. I was hoping for something a little more conclusive for this video, but that's just what you get. It's when you look into something, you can have some thoughts and opinions on what you're going to find, but you don't know what's going to get it. When we looked at the wingtip, when we looked at the nav light, the noise signal we were seeing wasn't nearly as strong as what we were expecting, and we found out why. So that's not even an LED fitting back there, but I think that there was noise that was getting carried through the wiring that I was picking up over there. The tail lamp is an LED. Yeah, we see 2 big humps on the frequency domains, and that's kind of right in that band where where we're trying to talk. We're trying to talk to each other in the air. There we go. So away and toward and away and toward. So we're seeing that amplitude in the time domain there, and we're seeing that what frequencies all this noise is spread across in the red line there in the frequency domain. That's getting right up to 0 decibels, the 0 decibel line, so that's pretty significant. And I think that's what's making our radios kind of get a little squirrely there. So it's nice to kind of track it down to a piece of hardware. I mean, maybe we want to just, there we are. So now we have the same circuit on. Without that lamp, we're not seeing any, without that lamp, we're not seeing any of that interference up there. So that would probably need to be replaced. It might be nice to, take that off and run it on the bench, just to confirm that the noise is in that device and not on the circuit somewhere else. But, any LED thing is going to have a DC to DC converter in it, and that's a noisy piece of electronics. I thought the problem was that LED light on the wingtip, because that light had gone out at the same time we started having the issue with the static. We were seeing that interference in that airband VHF range very, very strong from the tail lamp. So I've got that lamp here. It's a LED retrofit fixture. This goes into an original housing, so this goes into the light fixture that was already on the airplane, which means that the LEDs and the driver for the LEDs, that's a DC to DC converter that brings the voltage down from 24 to 28 volts down to whatever, usually a white LED is going to be around 3.5 to 3.7 volts. So there's conversion going on in there, and it's that converter I look for there's noise in a system, because the converter's got a switching circuit to bring that voltage down. It's turning the power on and off very quickly, and that switching is what can create the noise and interfere with the radio. So now I've got the lamp here, and I've got the oscilloscope on, and I've got my radio, and we're just going to go ahead and power this thing up. So I've got this set on. We're going to go up to aircraft voltage here, so it's a 24 volt system. So let's just go to 24 volts here. I'm going to leave the current limiter on 250 milliamps, and let's see if the lamp lights. Oh, there it does. Let's get this radio going. Now we're just going to light the lamp here, and see what the reaction is. Oh, look at that. Splendid. So this lamp is emitting the noise that is interfering with the VHF radio. So here's what we're doing. We're removing the hoop, removing the probe next to the light bulb. And I've got the red line on the oscilloscope zoomed in on basically 105 to 140 megahertz, so somewhere around there. 120, 10, about no, 95. This is about 95 to 145 megahertz. So that red bar or red line down there jumps up. That means that we're seeing interference in the VHF airband. And there it goes, right from that bulb. So that was probably, I mean, it's not as, I'm not picking it up as far away from the bulb as I was when it was in the aircraft, which is interesting. That probably means that the wiring inside the aircraft was acting as an antenna and helping to broadcast this noise. In the end, like this, you know, this DC converter in this light retrofit lamp should not be making that kind of interference. So there we go. This lamp is not going to interfere with my radios again.
You know, we got back here and landed, and then I came back to debug this on the ground and started going through turning things on and off. Pretty quickly we found that it was the nav light circuit. So I immediately think like, oh, this is an LED light bulb problem. One of my passion areas in electronics is understanding switch mode power supplies. So that happened to be like the first thing that would occur to me. It's like, okay, there's got to be an LED light bulb in there somewhere with a power converter that's spamming out a bunch of high frequency noise. We had a mechanic. There had been a couple of squawks that hadn't been reproducible already on the related to radio or GPS losing lock over, kind of leading up to that point. We had a mechanic and an avionics shop take a look at it, but neither of them could find anything. So because this interference showed up when we turned on and off the nav light circuit, we knew it had to be related to a light bulb. We could have just pulled all the light bulbs and tested them individually, but you got to justify that oscilloscope purchase. So the first thing I wanted to do was build a cheapy H-field probe, come here and go all over the aircraft. And just in case it wasn't a light bulb either, and try to find that interference source. So we ended up doing that and verifying that it was one of the light bulbs. It was the tail lamp that was spamming out all that noise and making the radios go crazy. And I'm not sure that this is a failure mode a lot of pilots would think of right away. I know quite a bit about LED lighting and power supplies, and it didn't occur to me while I was in the air. What happened to light bulbs such that they can create interference with radios? LED light bulbs have very complex power supply circuits that, by the nature of how they work, will interfere with radios. And they need to have a bunch of mitigations in the design to ensure that they don't interfere with radios. And so that design needs to be thought through really well, and the manufacturing process has to be really consistent using high quality components to make sure that every product that comes off the line is not going to interfere with radios. And that contributes, a big part to you get what you pay for and the quality sometimes. And I think I'm going to go fly it right now.
So if you're still here, I hope you enjoyed that. Next up, I've actually got some of the flying that Thad did with Dave while he was in town. He was kind of trying to overcome some trepidation around unusual attitudes and so on.
I'll place this camera when you've got the canopy shut.
Gonna ease up about 30 degrees, and now I'm gonna start my roll. Lots of rudder involved. And a bunch more coming out, stay on heading. And there it is, and then ease up. That's a roll.
That was lovely.
Not dramatic at all. I'm gonna go right into the loop if you're fine with it.
Yeah.
All right, so we're gonna dive for 150 on this one. Here comes 145, 150. Full power. And idle power. the loop.
We went all the way around.
Are you good?
Yeah.
Oh, it's awesome that if you're not queasy, you're going to be able to do aerobatics.
Yeah?
Oh, yeah.
Oh, marvelous.
So you survived that?
Hello. Goodbye.
That was the lizard brain.
It went back to sleep.
Oh yeah?
Yeah.
Nice.
Yeah. Now it's in pilot brain. We just go.
Let's go.
We just go.
Yeah, it was good. We did 2 spins to start, just to go right to the thing that he was most lizard
Jeez,
brained about.
okay. That's a lot.
Well,
I would have done like some gentle wing overs, but
No,
okay.
but-
Well, we did our clearing.
There's a
turns.
reason why. There's a reason why I started there, because it wasn't to see if he was going to get nauseous. It's because
You want to see me
he's
freak
got
out?
a mental block on the airplane's going to be. It's going to kill me. It's a lizard brain thing. That the airplane's going to kill me. So I'm like, let's just get the most intimidating thing out of the way first. So I went up. I did a deep stall, and it wanted to spin, and then I recovered that, and then I spun it 1.5 to the left, and then I did another 1 2 turns to the left. I was mostly at that point just trying to get a perfect 2-turn spin, which got on the second
You
try.
did a real good job. Yeah.
Yeah.
And then I'm like, now you're good for acro. He said he was fine with the spins. He's like, I'm fine with the physics of spins.
Yeah.
Like this, it makes sense. And then we
It's just getting heart rate, stomach,
Yeah.
all that stuff.
I don't think he's gonna have a problem with doing acro. Like he didn't get nauseous at any point. We did several loops. I did a Cuban 8. I did some rolls, some point rolls.
Did you give him control for any of that, or you just did all of
I
that?
flew home.
Flew me
Okay.
home. No, I didn't want to get into handing over controls in acro when I'm in the front seat. I'm gonna get him to do some.
It's just a lot to ride for that long with no control of that kind of maneuvering, but if you got through it, then
Yeah, it was
There's a
all,
lot of risk handing over controls in an acro scenario. A lot of risk. So I don't.
well, even if you just got him to do some steep turns in the middle, I'm just saying between maneuvers.
Right, but he wasn't getting nauseous.
Okay.
It's not a nauseous thing we were fighting.
No,
This is something else.
that feels good.
It's fun, right?
It's a lovely airplane too.
Yeah, this is the gentlest.
It was a great
coolest-
time.
Yeah.
My
It-
Cuban was like, son of a bitch. Every time in this thing, I always roll left on the one half and then right on the second half, and I'm always 90 degrees out on the second. Perfect on heading on the first, perfect on heading in the second loop, and then on the down line in the second, I always end up like somehow 90 degrees off heading when I'm pulling level.
Huh.
But somehow it was still fun.
Yeah. It's fun. Doesn't matter if it's not precise.
Yeah,
Okay.
well, I try for the precise.
Yeah. I know you do. You're Dave.
Thanks, buddy.
Okay. All right, let's go. I just cleaned some bugs off lenses. Holy shit, were they? There was even some dead bug guts on the inside, so I took them apart. So if you made it to the end, I hope you enjoyed that one. And I seem to be using this awesome shot as the extra for pilot nerds because, well, it's awesome. And please let me know in the comments what you think about this format. So far, it's working well to use things I've shot for Flight Chops that didn't really have a home on that more mainstream channel, and it's kind of liberating to be able to share the longer version of the deep dives here. And this is also a venue for more of my pilot nerd buddies to contribute to the content. So I'm looking forward to more of that, and until next time, stay nerdy.